All right, let's jump right in. We all see that AI is learning at this absolutely insane pace, right? But what if we're teaching it in a completely backwards way? Today, we're going to look at a pretty groundbreaking new way to train AI, and it's inspired not by these giant, powerful supercomputers, but by something much simpler: the way a kid learns a bedtime story.
So to really wrap our heads around this, we have to start with a comparison that is, well, it's kind of staggering, and it gets right to the core of one of the biggest problems in artificial intelligence today. Just think about this for a second. By the time a kid hits their 13th birthday, they've heard and read roughly 1 billion words. That seems like a ton, doesn't it? But then you look at a top AI language model. For it to get to its level, it chews through something like 10 trillion words. The difference is just, it's wild. We're talking about thousands of times more data for the AI to get to a similar place. And that brings us to the big question, the one that's driving all this research. Why is there such a massive gap? Are we just brute forcing this? Just throwing mountains and mountains of data at our AI, hoping for the best? Is more always better?
To answer that, first we got to understand how most AI models are learning language right now. It's a method that's definitely powerful, but as you're about to see, it is incredibly inefficient. It really is the brute force approach.
So the standard way we do this is something called next word prediction. It's pretty much what it sounds like. We feed an AI basically the entire internet, and its only job, over and over and over again, is to guess the next word in a sentence. Imagine trying to learn how to speak by reading a trillion-word dictionary, but with no teacher, no context, no pictures, just guessing what word comes next.
And look, this method works. It's given us this super powerful AI we have today. But it's not really learning concepts like you and I do. It's just getting ridiculously good at pattern matching on a global scale. And that takes an absolutely mind-boggling amount of data and energy. So, a group of researchers came up with this really clever solution. They thought, what if instead of just force-feeding an AI the internet, we could send it to school? A storytelling school, to be exact.
The whole idea is actually pretty simple, but it's also kind of profound. A kid doesn't just listen to words passively. They tell a story. Their parent goes, "Oh, that was great." Or maybe, "Wait, that part doesn't make sense," and the kid adjusts. They learn. So the question is, what if an AI could do the exact same thing?
So they built this elegant little learning loop. Here's how it works. First, a student AI, in this case a model called GPT-2, gets a prompt to write a short story. Then, a more powerful teacher AI, Llama 3, reads the story and gives it a grade. And finally, the student AI looks at that score and uses it as feedback to try and do better next time. It's that simple: student writes, teacher grades, student learns. But what was on this AI report card? Well, it wasn't just, did you guess the right word? Nope. The teacher was grading on these high-level, very human concepts. How readable is it? Grammar and flow. Does the story actually make sense from start to finish? Is it coherent? And this is the really cool one. Is it creative? Okay, this is where it gets really, really exciting. They ran this whole experiment, and the results, they weren't just good. They were a total game changer. This is the big aha moment of this whole thing.
So what do they find? Well, it all boils down to this one number right here: 410 million. Just keep that number in your head for a second, because what it stands for is pretty much the whole point.
And here it is, the punchline. The student AI learned just as much about telling a good story from only 1 million words of this interactive teacher feedback as a similar AI learned from 410 million words of the old brute force training. Let that sink in. This feedback method is over 400 times more data efficient. That's just incredible.
All right, so it's way more efficient, we get it, but what skills did it actually get better at? Was it just, writing sentences with better grammar, or was something more interesting going on?
This chart tells a really cool story. If you look at the bar for grammar, there's almost no change. The AI was already pretty good at that stuff. But look at the bar for story coherence. Whoa! The biggest gains were in these functional skills, like the AI's ability to actually keep track of characters and events throughout a story. Its accuracy on that specific skill jumped by almost 3 whole percentage points. It wasn't just learning to write prettier sentences. It was learning to tell a story that actually makes sense.
So this is obviously a huge deal, but like any good story, there are a few twists. The results have some really important details that kind of point the way for how we're going to build smarter AI in the future.
And here's the first catch. You can't just take an AI on day one, when it knows absolutely nothing, and enroll it in storytelling school. It turns out the student model needs a basic foundation of language first, otherwise the teacher's feedback just goes right over its head.
And this led them to discover this learning sweet spot. It's kind of like a Goldilocks thing. An AI with too little training couldn't learn from the teacher. An AI with way too much training was already so good that the feedback didn't make a huge difference. But that model in the middle, the one with about 90 million words of pre-training, that was the star student. It knew just enough to understand the lessons, but was still new enough for that feedback to be incredibly helpful.
And hey, you don't have to take my word for it. The researchers themselves put it perfectly. They concluded that their experiments show that interactive feedback is, quote, highly data efficient for storytelling. And then they say that this result really highlights the data inefficiency of just predicting the next word. It shines a really bright light on how wasteful the old method is.
So what's the big takeaway from all this? The big picture isn't just about saving some energy or computing power. It's about a really fundamental shift in how we think about building intelligence. We're moving away from an AI that just predicts text to one that can actually be taught to understand abstract ideas like creativity and making a story hang together.
And that, of course, leaves us with a final, massive question for the future. We've just seen that teaching an AI in a more human-like way makes it learn way more efficiently. So if we keep going down this road, if an AI can learn more like us, could it one day start to think more like us too?